Remember the inverting op-amp circuits. Inverting op-amps. An op-amp positive terminal is connected to the ground, negative terminal is connected to the output with a feedback resistor and source voltage R1. Okay, this is an inverting op-amp circuit. What does it do? It gives an output of minus RF divided by R1 times V in. Okay. So look at the gain. The gain is always negative. Okay. It's the inverted shape. So how can we design an op-amp circuit which has a positive gain, which has the same shape, okay, not the inverted shape, but the same shape? Do you have an idea? Look, what happens if you connect the source not through the negative side terminal, but if you connect the positive terminal, what happens? Look at the same circuit. But now I will connect a source to the positive side. This is RF. R1. Okay, let's analyze that circuit and see what happens. What does it do? What's the current on the inputs? 0, 0. Okay, I know that that's always 0. I minus 0. Now, this is V source. What's the voltage of V plus? What? V source. Good. Is there negative feedback in this circuit? Is there negative feedback? No. Negative feedback means a connection from the output through the negative inputs. Is there a negative feedback? So if there is a negative feedback, this is yes. So V plus should be equal to V minus. I know that V plus is V source. So V minus is equal to V source 2. Okay, I know this voltage. That's V source. That's V source 2. Op-amp causes that voltage. How can it cause? It changes the outputs. Okay, it changes the V out voltage such that minus V in, this point, is always equal to this point. So let's apply KCL on V minus and see what happens. What is this current? What is this current and this current? Can you say me the equation that gives this current? Positive side node voltage. What? 0. Minus this voltage. V source. This voltage is V source. Divided by resistance. Okay. Plus. What is this current? V out minus V source divided by RF is equal to this current. What's that current? 0. So from here, minus V source is equal to, divided by R1 is equal to minus V source plus V out divided by RF. I have carried this part to the other side, and from here V out is equal to RF divided by R1 plus 1 times V in. Okay. If you extract V out here, you will see this. So this is an amplifier. So what can be the minimum gain? What's gain? Gain means V out divided by V in. What can be the minimum value of this? If RF is 0, we know that resistances cannot be negative. Okay, they can be at least 0. So minimum gain will be 1. If this is 0, 0 plus 1 is 1. So if you increase RF, it increases. Okay, it can go very high values, and it's always A is V out divided by V in, which is equal to RF divided by R1 plus 1. Okay, so it's always positive. Always positive. Okay, so this is called non-inverting op-amp circuits. Okay, what does it mean non-inverting? It's not inverting the polarity of the signal. Okay, non-inverting op-amp circuits. Okay, this shape. What is the difference between the inverting? Everything is the same, but you change the position of V source voltage. Okay, if you carry the source voltage to the positive input, it will be non-inverting. Okay, inverting and non-inverting, you change the position of source voltage.